All right, I'm sorry for this abundance of information here. I just created a whole video and then it said error negative 5351 something and cannot believe that. So I'm gonna walk through this. All right. The I know it looks like a lot, but all the work is here, and hey, you won't hear my screen tapping the whole time, so I guess there's a plus. Uh, well, consumer surplus. Wonder if I just want a mouse here. Oh well. Okay, some consumer surplus here. The how this works is we have this equilibrium point where supply and demand meet. Okay, what we need are two values. We need that X value, the quantity, and what the price would be listed at. The the X value, just like before, right? That's where we are integrating. I need an area under a curve. Now the book explains really what a consumer surplus, producer surplus is. You can Google it. I want to look at the math here. So in pink, I have this demand curve, and the area between this price right here, that Y value, and the demand curve I highlighted in baby blue, that is what we call the consumer surplus. The area below the price and the supply curve, which I highlighted in orange down here, okay, that's what we call the producer surplus. And the area between two curves, we subtract the upper minus the lower, right? Some of the questions will give you this equilibrium point or give you the X value they want you to stop at. This example I chose does not. So the first step we do is actually set supply and demand equal to each other to find that equilibrium point. So I did that over here on the right. Okay, this is what we did first. I didn't like the fractions, multiplied it by 100. Solve for x is pretty straightforward from there. And that, remember, x is the a. Well, what they give us is a in the book. And the y is the b. To get y, we just had to plug in that x. Into either one, we'd get 10. Okay. Pause for a second, let you look over that. Now, consumer surplus, like we said, we're taking that top curve, that demand curve, and subtracting that price that we just got of 10. So we took this top curve and subtracted the 10. Okay, from here, pretty easy. Integral 12 minus 10 is 2, and then I changed it to 1 over 50x. Did the integral, substituted 0 and 100. Again, 0 we didn't need, and we get 100. So 100 is the consumer surplus. The producer surplus, it's backwards, right? We need the area under that price, the 10, subtract the supply function here, the lower curve. In my video, I'd actually messed up. You don't get to see that, but that's okay. I did not put parentheses here. Bad mistake, right? And I didn't distribute this negative, and I actually had 15 here. Okay, it's the upper minus the lower. If there's more than one term, distribute that negative. Pretty easy integral. Once again, substitute the 100. We get 250 for the producer surplus. Pause the video as needed, check it out, look over all the calculus there. But let's move on to the next example, a future value question. And this is of continuous compounding interest. So it's a special formula. We have this E here. Okay, so the future value is just how much is this investment worth after these terms happen. So in the example, we'll have 5% rate for 3 years, and they're investing $1,000 per year. Okay. R is a rate, capital N is the number of years, not lowercase t. That stays a variable. Notice we're integrating with respect to t. We don't want to plug a t in because then we'd integrate a constant. Okay. So substituting all those values in, then I distributed the 0.05 right here. They kind of work around how to integrate this. So I explain it over here to the left. You've learned e to the kt, so let me erase this plus c really quick. You've learned e to the kt integral is e to the kt, but then you divide by this constant k, okay, whatever that k is. Well, if we had some other constant up here, and we'll learn a lot more about this later and what to do, what if it isn't just linear like it is here, but a constant wouldn't change. And ultimately it's because the derivative of a constant is 0, but again, we will look at that later. For now, know that integral of e to the kt is still e to the kt, but if I have a plus c there, it also stays e to the kt plus c, and we still divide by k. So therefore the integral that we have over here, e with this ugly mess, is still e with that ugly mess, but we divide by that k, right? Negative 0.05, there's the k. And the next step, because that's constant, I just pulled it out front, and we substituted 3 and we substituted 0. We have to substitute the 0 this time, right? We don't get 0. So we'd actually get e to the 0.15, but when we substitute 3, we get e to the 0, right, which is 1. And then it's a word problem, and it wants to know money. It'd be weird to state, so how much is the investment worth, you know. I mean, I'd probably divide this, but something with an e in it, like, okay, well, how much money is that? I have no idea what you're talking about. So use a calculator. I rounded the nearest dollar. I got 3,237. If it wants rounded in the nearest cent, go ahead and do that. This one would have been 3,236 and 68 cents. Okay, I'm not too picky. Dollar works perfect.